So next talk is Adam Schneider from USNO, and he will talk about the WIRCam survey for the North Polar Cap. So we move to another instrument.
Thank you for this opportunity. My name is Adam Schneider. I'm an astronomer at the U.S. Naval Observatory. I'm at our Flagstaff station in Flagstaff, Arizona. And with some of my colleagues at our headquarters in Washington, D.C., we're going to present to you our idea of doing a survey of the North Polar Cap with specifically WIRCam on CFHT. So I'll give you a bit of info about what we at USNO have been doing lately as far as big surveys go, why we think doing the polar cap at CFHT would be a good idea, and then what it would take to do that kind of survey, and if we have enough time, some of the science that we're hoping to get out of such an effort. Okay, so if you are unfamiliar with USNO, we've been in the business of large area surveys for quite a while. You may be familiar with the USNO-A and USNO-B surveys that have been out for quite a while. There's also UCAC, which has several different data releases, NOMAD, URAT, just to name a few. So while we've been in this business for a while, with Gaia coming out and as well as a number of other surveys, especially Pan-STARRS and DES in the south, and then looking ahead to things like Rubin, the need for large area optical sky surveys is somewhat lessened as of late. But what about the infrared? So one of the things that USNO has been leading for the past few years is something called the Ukert Hemisphere Survey. So this is a partnership with the IFA and our European collaborators at Cambridge and Edinburgh to do a deep near-infrared survey of a big section of the Northern Hemisphere using one of CFHT's neighbors, Ukert. And as it scrolls through the coverage maps here across the screen, J-band is kind of what complete coverage looks like. After that, you'll see K and H, and then Y, which is kind of just getting started. Clearly, that's not wavelength order, but it's the order which the surveys were done. So J-band was done first, then K. So the J-band survey has been publicly released. That was in 2018. K-band survey was in 2023. The H-band survey we expect to release later this year. And then we're actually doing Y-band plus a second epoch of J, which we think will have a lot of value. And that's ongoing, and we expect that release in a few years. And you can look at the median depths of these different surveys, and we're going 3 to 4 magnitudes deeper than something like 2MASS. And so we're really exploring a lot of new space with these surveys. To compare to Gaia really quickly, so what I'm showing on the left is the fraction of stars that have a Gaia counterpart. Sorry, not just stars. The fraction of objects in the K-band survey that have a Gaia counterpart. And so you can see that fraction decreases significantly as you get to fainter magnitudes. And then the histogram on the right is just showing the number of objects in the K-band survey as a function of magnitude. And that's where most of the objects in the survey live, unsurprisingly, are at faint magnitude. So something like half of all the 400 million detections in the UHS K-band survey do not have a Gaia match. So again, we're exploring a lot of new parameter space here. One thing you may have noticed about this coverage map of the Ukert Hemisphere survey, besides its beautiful yellowish brown green color, is that it has a really weird shape, but that shape is actually very deliberate. It's meant to be very complementary to previous surveys that have been done with Ukert, specifically the UKID survey. So if you fill in those gaps with the Large Area Survey, the Galactic Plane Survey, the Galactic Cluster Survey from UKIDS, you're seeing pretty continuous coverage from 0 to something like plus 60 in the Northern Hemisphere. What's more is if you look at the surveys from VISTA in the Southern Hemisphere, VISTA is a similar size telescope to Ukert that has a very similar depth and resolution. We're getting almost complete coverage in the near infrared from minus 90 to plus 60 across the sky. You may note that there's one area of the sky that has not been surveyed yet at near infrared wavelengths to this depth, and that is what we're calling the North Polar Cap. So that's above plus 60 and it's some 2,800 square degrees. The reason UCURT can't do this is because because of its mount, it has this hard mechanical limit at plus 60 degrees. So UCURT just can't reach that area. And if you're like me, you're thinking it would be such a shame if this area was never surveyed to similar depth and resolution. So maybe we should all do this as a team, and that would be a wonderful idea. So that's where CFHT and WIRCam come in. We actually looked at potential other options for this kind of survey, and there are not many good ones out there. So CFHT and WIRCam are really a nice combo that would help complete this type of sky survey. But we don't have to do it all. So there's actually a smaller amount of sky that we'll have to cover because of Euclid. So this is just a different projection of the sky, so we can see the northern cap a little more clearly. Again, Vista below 0 degrees, UCURT from 0 to plus 60, and then above 60, what you'll see in the yellow shaded region is where Euclid will cover the sky much deeper than we're doing with anything at UCURT at Y, J, and H band magnitude, at Y, J, and H filters. And so we don't really need to survey that area if we want to be relatively efficient with such a survey. So what we're proposing is something in the red box that you'll see at the top, excluding that area of Euclid. So what will this take kind of time-wise? So these are a little better than rough numbers, but they may be a little squishy in a few areas. But I'm going to focus on the table on the right, which is excluding those Euclid areas. WIRCam has this really nice field of view of 20 arc minutes, which is great for surveys. And so we expect if we allow for a little room for overlap while you're tiling, and then some dithers to cover the gap between WIRCam detectors, about 10 pointings per square degree is what we're anticipating. So the area to be covered would be the whole sky at K, which Euclid doesn't do, but then around 1,750 degrees for Y, J, and H. Multiply that by 10 for the pointings per filter. Total pointings is around 80,000. About 60 seconds is what we anticipate to get a similar depth as the previous UCURT surveys. And if we suggest 5 hours per night at CFHT, that's 270 nights total. So it's a decently large number, but not what I would say is an unreasonable idea for what we might want to do at CFHT. Personally, I am a brown dwarf enthusiast, so I would love to see a near-infrared survey of this part of the sky. So brown dwarfs have usually characteristic colors as a function of spectral type, but we can look for oddballs, which is something I like to do, and I've been doing in the UCURT hemisphere survey. So what I'm showing on the right is an example of an object that we don't have a detection in pan-stars, although I think it's there a little bit. And in 2MASS, it's detected at K, but not at J. And we really needed the J-band detection at UHS to put it on these kinds of color magnitude diagrams to show what an outlier it is. This one just happens to be a really, really red, free-floating planetary mass object that, again, UHS had a really prominent role in helping to discover. I'll also note that these types of surveys to do substellar science are not unprecedented at CFHT. There was the CFBD-SIR survey, which covered some 330 square degrees not too long. Another of my colleagues at USNO is really interested in these dual active AGN, so this is Barry Rothberg, along with his collaborator Ryan Feifel, are looking at these interesting AGN sources that they're finding with mid-infrared data in WISE, and then using the higher resolution near-infrared data from things like UCURT or Vista surveys to really look at the morphology and structure of these interesting systems. So a lot of info here. This is not my area of expertise, but feel free to read on this if you want. So that is our idea for the Northern Cap survey, and these are just two of the many science cases that I think could result in such a survey. And hopefully you can see how it's complementary to existing, ongoing, and even future surveys. And so I think there would be quite a bit of legacy value to having such a survey. So that's the idea. I'm happy to take a few questions if there's time.
So questions for Adam? So the magnitude you quote is 18 AB, or it's everything.
Sorry, those are Vega magnitudes.
Those are Vega.
Mm-hmm.
So which mean K20 in AB, right? In this sense. And if there is any, do you absolutely need all the band from Y to K, the 4 bands?
So that's the preference, is to have the full coverage. Of course, we could, if we needed to trim, we could find a band that we find maybe slightly less valuable than the others, but our big ask is for all of it. But yeah, I don't think all are certainly necessary. Absolutely necessary.
And for the Y, you need gray time, or?
That's a good question. We're working on some kind of test observations to see what's possible, and I would have to look into whether we need gray time or not.
Okay. Yeah. What's small question for the CFHT? I mean, I believe there is also maximum tech you can go to. No, I just asked.
Hopefully, we got that right. I don't think there is.
I think there is no constraint on that. There is no technical issues to go at high declination. That's right. Kevin is no put. So it should be okay. Technically. Other questions for Adam? So, thank you, Adam.
Thank you.